Slave replication. Master-slave replication, also known as a primary-secondary replication, is a replication model where one database server referred to as the master or primary is responsible for handling all write operations, while one or more slave or secondary servers receives or receive and store replicated data from the master, and they serve the read operations. The slave servers are typically used for read operation, as we said before, allowing for load distribution, improved performance, and redundancy. The setup has a master or a primary, which is this server handles the write operation, and we have a slave database or a slave node which handle the read operation. So let's talk about how it will look. So we have right now a server. The servers should communicate with the database, okay, to fetch data, to read or write data, okay, database. In the master slave database, we will have more than one database server. We have a master database, like master DB, and we will have two slaves. Let's go with two slaves for now. Slave 1 and slave 2. And the master slave, as we said, it support all the write operations. And when the records or resources have been created or edited or deleted, the data should be replicated across the slaves. So replicate, and here as well, replicate. And when the server trying to request to read the specific resource, it will send the request to the slave, because the slaves serve the read requests. So for now, it will send, let's say that it will send to this slave, it support read request, or it will answer the slave number 2. So let's talk about how it works again. So first we have the data writes to the master. The client or the server sends write requests like insert, update, deletes to the master database. The master database processes the request, updates its local data store, and logs the change in its binary or transaction log. After that, we have the second step is to replicate to slave servers. So after the master completes a write operation, it sends the changes, which is like the log entries, to the slave servers asynchronously or synchronously. There are two ways that we can discuss them as well, maybe in this video or future video, depending on the replication model. And the slave servers then apply the changes to their local data store, keeping their data in sync with the master. Let's talk about the read operations. So read requests such as select queries can be directed to one or more slave servers, reducing the load on the master, since slave servers are only replicas of the master. They can serve these read requests without impacting the write heavy masters. There is also a failover, which is optional, like in event of the master is failed. Okay, in the event of the master is failed, one of the slaves will be promoted to be to the role of a master to continue operations, to continue the operations, or to continue operating. And this overall process can be manual or automated depending on the system architecture. So as you can see right now, we have maximum availability. So we improved first, we improved the read performance, because by offering read operations to slave servers, the master is free to focus on write operations, and this improved the overall system performance, especially in read heavy workloads. Scalability as well, because the system can scale horizontally by adding more slave servers to handle read traffic. This reduces the burden of master on master servers and ensures that the system can handle more read requests without affecting write operations. Also, It's great in availability. So if you have a master has been fallen, one of the slaves could serve as a new master. If one of the slaves have been fallen, we have one all the read requests will go to the other slave. So we improved the redundancy and fault tolerance, because having multiple slave servers ensures that the redundancy, making it easier to recover from failure. If the master server fails, a slave can be promoted to a new master, minimizing downtime. Also, there is a disaster recovery, because slave servers can be geographically distributed to provide disaster recovery options in case of failure in primary regions. Geographically distant slave can take over the options, and there is also a backup and maintenance, because backs up and heavy queries and heavy query can be run on slave servers instead of the master, reducing the impact on write performance. This ensures that the master remains performant for write heavy operations. There are multiple challenges comes with the master slave architecture. For instance, a replication lag, write scalability, failover complexity, also consistency issue, and a single point of failure. I guess there is not that much single point of failure, because we can talk about if one master fail, we have a single point of failure here, but we can just promote one slave to be a new master. So the talking about single point of failure is not lesson. It's not practical to talk about that currently, but there is a big problem in consistency and how to solve this one, and also in the failover complexity. There are two ways of actually how data being replicated. There is a synchronous way and asynchronous way, but I guess it will be overhead of like it will be not. I guess I will not talk about about it in this video. In this video purpose, just to talk about high level on how the master slave replication works, and after that we will talk about how the replicated is working depending on the difference between synchronous and asynchronous. We could talk the use cases of the master slave database, like it's working in the content delivery networks, database backups, a high read, low a high read and low write workloads. It works in analytics and reports. It works in many different applications. I guess you will face it a lot in your system design interview. So this was like a high level on what is a master slave replication. So master slave replication is widely used technique for improving read scalability, fault tolerance, and data redundancy. It's particularly effective for read heavy applications, ensuring that the master database is not overwhelmed by read requests. However, it has limitations in terms of write scalability and consistency, especially in asynchronous replication setups. Choosing the right replication strategy, monitoring replication lag, and automating failover processes are crucial for effectively managing a master slave replication architecture. So that's it for this video, and see you in the future.